guys. Today we're going to do a review over definition of derivatives using the difference quotient with a limit approach. So if we remember what that's going to be here, that would be the limit as h approaches 0 of f of x plus h minus f of x all over h. And by doing this, we're going to be able to find the derivative of a function. So for the most part, you've probably see this as being a tedious way or something that's just a painful way of finding the derivative, since throughout the year we've actually learned different ways of finding the derivative. So if we were given this function f of x to equal a negative 2x plus 5, we would be able to find this derivative in several different ways, but in this case we're going to use the difference quotient. And some of you will just use the power rule and tell me that the answer of this is going to be negative 2, and that's fine. But if it asks you to use the difference quotient or the definition of the derivative, we're going to have to use this equation here. So we're going to have the limit as h approaches 0, and using the difference quotient here, we're going to take that x plus h and plug it in anywhere there's an x in this function f of x. So we will have negative 2, and inside the parentheses there, since there was an x, we're going to put in x plus h, and then plus 5. So that's the first part. That would be equal to what this equation is saying there. And then now we have to subtract the whole original equation. So a lot of times people here, they'll just put a minus and then they'll start writing the equation, and they won't make it to where that negative goes to the whole equation. So make sure, let's go ahead and put it in parentheses here so we can see that that negative is going to go to everything. And then now at this point we're going to just divide that by h. And the way we can evaluate limits is just by taking this 0 and plugging it in and evaluating. But we can see here that we're going to have a problem, because if I just took this limit and evaluated this and took the 0 and plugged it in, it would cause a 0 to be on the bottom of a fraction, which we know gives us an undefined answer. So let's go ahead, let's simplify all of this and see if we can get it to where there's an h in every term, and then at that point we can factor out an h and cancel it. So I distribute the top, that would be the limit as h approaches 0. So we need to write that until we actually evaluate the limit. So it would be negative 2x minus 2h plus 5, and now we can see we can distribute that negative to everything. Negative times negative gives me a positive, so it would actually be plus 2x and then minus 5 all over h. Now at this point, let's combine like terms, and we know or we can remember and think back here, everything should cancel that does not have an h in it. So we can see that this negative 2x and the positive 2x here are going to cancel each other out. And then this positive 5 and negative 5 will cancel each other out as well. So now if I write this equation, after I simplify this, we would have the limit as h approaches 0 of negative 2h all over h. And now, since there's an h in every term, we know that we can factor it out. So by factoring it out, we would actually, just to show what's happening, this is an easier problem, we actually have a negative 2 times h all over h, and it's held together by multiplication, so the h's would cancel each other out, which just leaves us now with the limit as h approaches 0 of negative 2. Well, now we can evaluate this limit. We can take this 0 and plug it in anywhere there's an h. Well, in this case there's actually not any h's, so when I evaluate the limit, it's just going to equal the limit of a constant is just going to be a constant here, so that would just be equal to negative 2. And if we scroll back up to where we used our power rule, we can check to make sure that we have the correct answer. And I didn't write it down, but earlier we stated that the derivative should be negative 2. So at this point we're going to write this as f prime of x, and f prime of x means the derivative of, or the first derivative of this function f of x. Okay, so now let's use another example here where we have something that's being squared. So let's take y equals, now let's use f of x still. So f of x is equal to, let's say negative 3 x squared plus 4. Okay, so using the definition of a derivative using limits here, we will have the limit as h approaches 0 of, anywhere there's an x, I'm going to take an x plus h and plug it in. So I end up with negative 3 x plus h squared plus 4. Okay, so there's the first part of the difference quotient, and now I have to subtract the whole original function. So we get negative 3x squared plus 4 there, and all of that will be over h. So now, our next step, since we still have that h on the bottom and it's not in every term, is to go ahead and simplify this or distribute out whatever needs distributed out. So we haven't evaluated the limit, so make sure you're still writing the limit as h approaches 0 out front. So now I can fix this. This would be negative 3. And to fix x plus h squared, that would just be x squared plus 2xh plus h squared. And then we still have our plus 4. I'm going to go ahead and distribute that negative to everything, so that becomes plus 3x squared. And then we get a minus 4 all over h. So as I scroll down here, we can distribute the negative 3. Remember, we're still writing this limit out front because we haven't evaluated it yet. So I have negative 3x squared minus 6xh minus 3h squared plus 4 plus 3x squared minus 4 all over h. Okay, so now let's look. Anything that does not have an h in it should cancel, because we want an h in every term so we can factor it out and cancel the h that's in the bottom. So I look here at this negative 3x squared. We can see that there's a negative 3x squared and a positive 3x squared, so they will cancel each other. And then the next thing that does not have an h in it would be this 4, and that would be a positive 4 and a negative 4. So we've canceled everything out that does not have an h. So now let's rewrite this so then we can cancel out the h on the bottom. So that would give me negative 6xh minus 3h squared all over h. And to be able to cancel out this h, it needs to be in every term since it's held together by addition or subtraction. So I can see that there is going to be an h in the first term on top as negative x, or negative 6xh minus 3h squared. And just to write an extra step, we don't really have to, but let's factor that h out at the top so you can see what would be left. We end up with negative 6 minus 3h in the inside all over h. And since now it's held together by a multiplication, I can cancel my h's. Well, some of you are going to say, well, that h on top didn't cancel, but that's okay, because now when I evaluate the limit, I can just take that h equals 0 and plug it in. So now I'm going to evaluate the limit, so this f prime of x is going to equal negative 6x minus 3 times 0, because we took that h and we've plugged it in. And anything times 0 is 0, so that goes to 0. So the derivative of this problem should just be negative 6x. And like I said, you can always check yourself. Since it's later in calculus, you can use the power rule. And by using the power rule, we take this and we multiply it to the front, and that would give me negative 6x. The power goes down 1, so that would be to the first. And the derivative of a constant is 0. So there's where the negative 6x comes in. Okay, so that is the definition of a derivative using a limit approach. Thanks, guys.